All right, so let's take a look at this. So today we are going to be um, going over slope just together as a class, but not for very long. And then afterward, you're just going to get on Edgenuity, the new lesson, Intro to Linear Functions. It should be a review, everything that you've already learned in the past, introduction. You don't need to submit your notes. That's it. Okay, pretty basic, I hope. I know that the Edgenuity videos are not exactly the best in the world. I agree with you. If I had a choice, then I wouldn't be giving you guys Edgenuity, but unfortunately, every kid in the district has to be teaching or learning Edgenuity just because we have the online kids and the in-person kids, and just in case school gets shut down for whatever, an outbreak or whatever, they need a program to fall back on. So unfortunately, for better or for worse, that's what we got. But if there's anything in Edgenuity that you feel like you're still kind of confused on, then that's where we should probably get those questions answered as well. Okay, so do try to understand, pay attention, and really just understand what they're trying to teach you. Okay, and that's it for today. So again, you do not need to take notes. You do not need to write this down. I think you should be okay if you were to just listen and follow along. Okay, let me go into my other meet really quick. By the way, I know that some of you don't care, but I want to share this to you because whenever something happy comes in my life, I feel like I need to celebrate it because sometimes nowadays there's just so much unhappy. But I got these pens the other day. Have you ever seen these before? So they're like, so you like write in their pens, but then if you let it dry, they erase, and it's not even an eraser. It's like rubber on top. And so look, that's amazing. Thank you for sharing my joy. You see, I knew that you guys would be a good sport and share the happiness with me. That is insane.
How much can I buy one for?
A Benjamin. All right, here we go. So, this says find the rate of change. So guys, when we are, when we are talking about rate of change, remember that's the same thing. That sounds super official, but really they're just saying find the slope. Okay, find the slope of a line. So it looks like I'm comparing this person's time with the distance that it takes per time. So remember, when we find rate of change, or slope, what you have to do is grab 2 points that hit the corner of a square. So like, if you look carefully, like that doesn't really hit the corner. That's a little bit below. That's definitely below. That's above. That looks a little bit above, to be honest, but that looks smack dab in the center. So I would choose 2 points if I don't have points given to me. And then this one is the most obvious one, but you can also choose this one if you wanted to. It doesn't matter what 2 points you choose, as long as they hit the corner of a square perfectly. Does anyone remember from last year how to find or calculate slope? Yes, Tessa.
Don't you like count down and then count to the side?
Yes. So you do a lot of counting of boxes. Does anyone remember what those words? It's like an R and an R.
Wait.
Rise over run.
Yes, rise over run. Sure. So, one way that you can count slope is by doing something called rise over run. So, I'm going to show you a couple ways just because I want to show you it doesn't matter how you count them, but you should come out to the same answer. So, let's say, let me use my eraser and erase that. So, let me just choose these 2 points and count my rise over run. First of all, I always want to start from the bottom so that I can rise up. Okay, so always start with your bottom point. And it looks like I'm not counting by 1, so just keep that in mind. I know that for this one, it doesn't really make a difference because you're counting by the same number, 2s and 2s. But sometimes on your graph, you might be counting by 2s, and here you might be counting by 1s, which does make a difference. So just be careful, okay?
I have a question.
Yes.
Wouldn't it technically be the correct thing to do by counting by 1s and just like by 2s because it's
the same
simplified version?
Yeah. So so Garrett is basically saying if you're counting by 5s here and you're counting by 5s on the bottom, as long as you're counting by the same thing on the on the X and Y axis, then technically you could just say that you're counting by 1s.
Yeah.
But there's a lot of graphs now that you're in algebra, okay, high school, where you might be counting by 5s here, but you're only counting by 2s or 1s down here. So you have to be really careful because if you're counting by different numbers on different axes, then that does make a difference. Okay. All right. So anyways, I'm just going to count by twos just so there's not any issues or mistakes or anything like that. So start from here, from the bottom. I'm rising 2, 4, 6, 8 squares. And then on my run, I'm running over 2, 4, 6, 8, 10. So 8 over 10. That's not my slope, because remember, my slope is always going to be simplified. So if you are too lazy to simplify 8 over 10, that's okay. I am too. Join the club. Just type alpha y equals enter in your calculator, and that simplifies to 4/5. So you can say that your rate of change is 4/5, or you can say that your rate of change is 0.8. Like you can say for every 0.8 miles, I have traveled 1 hour. That's pretty slow, but it's also hiking, so he might be going uphill. Okay, so let me show you how, if I hadn't taken those 2 points, what if I didn't see this point and I chose this one and this one? It would still be the same thing, and let me prove to you how, okay? Because it simplifies as a fraction. So I'm rising 2, 4, 6, 8, 10, 12, 14, 16. I'm running over 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So 16 over 20, if I simplify it in my calculator, it's still 4/5, which is 4/5. So again, as long as you choose points in your graph that hit the corner of the square perfectly, then you should come out with the same answer, okay, which is 4/5. Okay, so that's how I can find rate of change. Let's do this one. I can't count rise over run because I don't see a picture to count. Does anyone remember if I have like numbers and points, how I can find the slope? Mason?
Isn't this like like X1, Y1?
Yes, something to do with X1, Y1, but then there's like a specific order and a formula. Yes, JC.
Isn't it like X2 minus X1 and then like the line and then Y2 minus Y1?
You're like 95% correct. You're almost there. You just made a really, yes, Y is on the top. Okay, so all of you this year have a star chart, just like you had one last year. And let me hurry grab it. Right here, this is your star chart. Look at all the amazing and complicated looking things that you're going to be doing this year. Like they're not even formulas, they're just letters, right? But here we go. This is the one, slope of a line, that's your formula. So let me tell you this, you guys as 8th graders are super, super lucky because you have a star chart. When I was in 8th grade and when I was in high school, we didn't have such a thing called a star chart. So if we had a formula, we had to memorize it. So because you have Miss Friesenhan as your teacher this year, you are very lucky because I get to sing all of my formula songs to you. So basically, since I had to memorize all these formulas in my head when I was a kid, I basically made really, really stupid songs to remember them. But guess what? I still remember them like 30, okay, I'm not that old, not 30 years, 25 years later, I still remember it, okay? So here's the formula for this, but the way that I made it up is I made it up as y sub 2 minus y sub 1 divide x sub 2 minus x sub 1, the end. And that's it. Okay. Thank you, Mason. You see, applause. This is why I know that I love Mason. Okay, but anyway, so that's how I find my slope, okay? So here's the formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the good thing is, if I sing it to you and annoy you enough, you're probably going to memorize it yourself. I still have students from like 10 years ago that I taught, and they're like, Mrs. Riesman, did you know that I still remember the slope song? That's because I sang it every day to them. So anyway, so here's my formula. So I'm just going to grab 2 points. Normally, I like to grab the 2 that are the smallest numbers, that are whole numbers, that are not decimals, that are not negatives. And I take my point as this. This is 5, 6, and this is 10, 12. So remember, whenever I have a point, I have x1, y1, x2, y2, because these are my first x's and these are my first y's. Okay, and then I just plug it in. So literally just plug it into my equation. Okay, so if I do that correctly, Carrie, what number is y2? minus, Carrie, what is y1? Thank you, over, Ella, what is x2? Minus, Ella, what is x1? Oh, whoa, that was weird. Sorry, Ella, what is x1? 5, thank you. Okay, please don't do the work in your head. I mean, why do that if you have this amazing, beautiful baby, right? So this looks like a big fraction, so hit alpha y equals enter. On top, just hit 12 minus 6. On the bottom, just hit 10 minus 5. The great thing for this is I know you can do this in your head, but does it simplify your fraction for you? And does it do negatives for you? Because some of us make silly mistakes with negatives. So anyways, this is 6 over 5. Do not change it to 1 and 1/5. Mixed numbers are no bueno anymore, okay? We like improper fractions for math. Always change it or use it as improper. So my slope or my rate of change is 6 over 5. So remember, that's like my y's over my x's. For every 6 miles, I have 5 hours that have passed. Or you can say 1.2. For every 1.2 miles I've hiked, I have, I've had, 1 hour that has passed.
Wait, actually, wait, are they driving or hiking?
I don't know. It says hiking, so I'm assuming they're hiking. Okay. But anyways, remember, if you were to choose 2 other points, like if you were to choose this one and this one, let's say, you would still get the same answer. It truly doesn't matter because it's linear. Because look at your pattern, +5, +5, +5, +6, +6, +6. Because it's linear, you're always going to get the same answer. Doesn't matter which 2 points you choose. Yes?
If it wasn't linear, would you choose?
So if it wasn't linear, Vaughn is asking, then what points do you choose? We would never ask you what the slope is if something's not linear, because if something's not linear and it looks like that, how can you find the slope? You're not going to have the same answer, right? We would never ask you that question. Okay, so let's do this one then. Can I zoom in a little bit more? All right, here we go. So I don't see dots. So if I don't see dots, always grab some that hit the corner of a square perfectly. So like this one is good. This one, I don't know. It actually doesn't look great. It looks like it's a tiny bit above the corner. This one looks like it's a tiny bit below the corner. So I'm honestly not sure, but this one looks pretty straight and center. So that's what I'm going to go with, okay? So remember, you can just choose rise over run and then go from there. Okay, it looks like we're counting by, what are we counting by on the side? Twos. You're counting by twos. And then on the bottom, you're also counting by two. So if you forget that you're counting by the same, like twos and twos, and you end up just counting by one, you got lucky. But remember, if you're counting by a number different here and a number different here, then that does change your answer. Okay, so I have 2, 4, 6, 8, 10, 12, 14, 16, 18. So I'm rising 18. I'm running over 2, 4. So 18 over 4, just type that in your calculator. It'll simplify and do all the math right for you, is 9 over 2, or you can say it's 4.5, right? Either one is fine. Normally, when we are using slope, we like to leave it in fraction form. But if we're talking about rate of change, maybe you want to change it to decimal form, okay? But it's your choice. All right, so last one. For this one, you would do the same thing, right? Let me choose these two because they both end in 0, so it's easy to do the math, right? So this point is what, comma, what? 20, comma, 10. That's how you read this, right? When you have a table, the X is on top, the Y is on the bottom. So you have 20, comma, 10, and then for this one, you have what, comma, what? 40, comma, 20. Good. When you label your like Y's and your X's with the 1s and the 2s, how does it go again? Okay, so I purposefully flipped them. Like normally I would do X1, Y1, X2, Y2, but I purposefully flipped them because I want to show you it's okay if you flip them, you would still get the same answer. Okay. The only thing that is wrong is if you put like X1, Y2, X2, Y1, like that would make it wrong, right? You would have to do 2, 2, 1, 1, or 1, 1, 2, 2. Okay. But my formula, Y sub 2 minus Y sub 1 over X sub 2 minus X sub 1 would look like On the top, Luke, it's what minus what?
20 minus 30. Wait, no, sorry. 10 minus 20.
Oh, yeah, sorry. See, I even got it wrong. I mixed them up because I'm so used to having that one. Thank you. 10 minus 20. And then Grant on the bottom is what minus what? Oh, Grant's not
He's
here.
online.
Okay, thank you.
He's
Sorry.
listening to you right now.
Don't worry, his brother.
I don't know, why isn't he here? That is so weird. I don't even know.
How do you not?
I know, right?
I feel like you would know this more than anyone else. in this
Wait, I was
room.
here. My mic was muted.
Oh, yeah,
Sorry.
I saw that.
That's okay. Okay, Grant's online. Grant, on the bottom is what minus what?
It is going to be 40 minus 20.
Perfect. Oh, wait, nope. Try again.
Oh, no. Wait, what?
X2 minus X1.
X2. Oh, it's 20 minus 40.
Yeah, I flipped them just on purpose. I know that you guys are
Yeah, I
used
did
to
not
having the
see that.
2s here and the 1s here. That's okay. I just want to show you though that if you flip them, you can still get the same answer. But type it in your calculator as one big fat fraction, so it'll do the negatives and the simplifying for you. You get 1/2. Okay, so ladies and gentlemen, that's how I find slope. That's basically what you're doing today. I have a trick question, or not really a trick question. Hopefully you know this. Let's say I have 3 people. This is Garrett. This is Luke. And let's say this is Luis. I don't know. I just grabbed 3 people in our class. Okay, so can someone raise their hand just by looking at these lines and tell us who is the fastest? Who goes the fastest in this class? Yes, Jack. What? Why?
I don't think it is.
You're right. Garrett is the fastest person based off of this graph. But why?
I can't even run.
Why? Vaughn.
I should probably roll it down the rest.
Okay, so Vaughn said that his line increases in the shortest amount of time. Hey guys, stop talking, please. That is the very correct mathematical term. Do you see how his line increases the fastest over the shortest amount of time? His rise over run is the biggest. Basically, you could just say his line is the steepest. The steeper the line, the faster you go. Okay, so unfortunately, and I'm sure this is not indicative of real life, and we'll race each other later or something. I used to race my students all the time because I used to run track. I only run the 100 though. But who technically in this picture is the slowest? Yes, Luis.
Me.
Yay, Luis is the slowest. Okay, Luis, why are you the slowest?
Because you're my watch, my why, like, doesn't go as high as fast as Garrett and Luke.
Yeah, so his Y does not go as fast. Basically, he's the flattest line. The flatter the line, the slower you go. The more steep your line is, the faster you go. Okay, so then let's say this then. Let's say I have 3 more people. Let's say I have Ella, I have JC, and I have Tia. Okay, let's say JC's slope is 1/2, whatever that means. Ella's slope is 3/4, whatever that means. And Tia's slope is 9/10. Okay, who is the fastest here if these were their stats? What do we think? Garrett, what do you think? What do you say?
Tia?
Okay, so she's the fastest, but why?
It's steeper. If it were to be slapped on the ground.
It's okay, well, but your rises over runs are different numbers. You're not comparing all the same denominator. So it's kind of hard to say that. But you're true, like this is right. Tia is the fastest, but why, Luke?
Well, if you compare them to decimals.
Oh.
Dude, you're a genius.
That's what I did. I
Honestly,
didn't know
he
if that
said
was
that.
So honestly, the only way that you can truly be accurate is converting them to decimals. The bigger the number, closer to 1, the faster they are. The smaller their number, sorry, JC. Oh. The smaller their number, closer to 0, that means that they're the slower one. Okay. I know this is not true, but I just made up random people and random numbers. Okay. So anyways, ladies and gentlemen.